Hey everyone, Kevin from MechanicalAdvantage.com. Now that I have this cylinder head modeled from the Autodesk Model Engine project, I'm going to use this video to add the cam toolpaths needed to machine the top and bottom sides of this part so I can take it out to the mill and run it and get the completed part. Wanted to take a second to let you guys know that I'm still running the promotion through the end of the month on training classes and support packages. You can get 25% off both of those options by either using the coupon code TRAIN25 or SUPPORT25. And I will put a link in the description to where you can find those classes as well as the coupon codes to use. I'm going to switch over to the manufacturer environment. And when I originally did this series, I uploaded a tool library for all the parts in the series. I'm gonna attach a new tool library to the description of this video, which is just a link to the OneDrive folder that I'm using. And I made a small tweak to one tool. Now, you can either download the new tool library, or if you wanna make the change too, what I did is I went to my tool library, and for my Autodesk Model Engine, I found my 3/8 inch end mill, and I changed for the aluminum finishing toolpath. So if I edit the tool and I go to the cutting data tab, if you find the feed per tooth for aluminum finishing, I changed the feed per tooth from 3 thou per tooth to 2007 inch per tooth, which changed the feed rate from 60 down to 90. I just wanted to slow the tool down a little bit to help improve the surface finish on my 2D contouring operations. So that's the change I made. You can either download the library or edit this tool and make that same change if you're interested in following along with what I'm doing. I'm gonna hit cancel and close, and now I'm ready to start adding my setup for this part. I'm gonna make this part out of the same stock. That is, it's gonna be roughly 2.5 inches in the X, it's gonna be 2 inches in the Y, and it's 1 inch thick. And when I create my setup, I'm happy with where the work coordinate system, I'm gonna leave it at the top dead center of the part. It already found the body that I wanna model. What I'm gonna do now is move on to my stock tab. And when I'm on stock, I'm gonna change my mode from relative to fixed size box, and note that I have no additional roundup. Here I have that set to 0. So that tells me that my part is only 0.337338 inches in thickness, and I'm cutting this out of a 1 inch piece of material. So let me go through and add my sizes that I want. So I'll say 2.5 for X, it's gonna be 2 in Y, and then for the Z, it's gonna be 1 inch in thickness. And when I look at this from the front, you can see I've got a lot of material I have to remove off, and I could split this difference, or in my vise, I have gripper jaws and it holds the material extremely securely. And so I think what I'd like to do in the first operation is remove as much of the material as possible so that when I flip it over and put it up against parallels in the smooth side of the jaws, I'm not holding it quite as securely, and I don't have as much material to take off in that setup if I machine the majority of it off in the first setup. So I'm gonna adjust my Z model position. Normally you see me do this from the top and do like a 10 or 20,007 inch offset. In this case, I'm gonna do it from the bottom, and when we do that, Fusion figures out the exact number to keep the part centered. On my gripper jaws, I need about 1/8 of an inch of clearance between the shelf that the part sits on and the top of the gripper jaw portion, but I'm gonna give myself a little bit of a buffer, and I'm gonna say that this is gonna be 0.2 inches. So that's what I'm gonna have to take off in my second operation, and the shear hog will handle 0.2 inches no problem at all. So I'm happy with that. I'm ready to look at my post-processor tab, and on my post-processor tab, I have my work coordinate system set to 1 by default, and that is going to give me a G54 out in the machine. So I'll hit OK, and I'm ready to start adding toolpaths. Hey everyone, I interrupt this YouTube video to bring you a message from the future. So I've applied the cam toolpaths, I have run the part at this point, and I went back and I started editing the cam video and the machining video, and I realized after running the part that I made some mistakes. And I was going to go through and point out some of those mistakes, but I thought it might be a fun game. Who can go through and spot the mistakes that I made? I'll tell you one of the mistakes that you might notice is for this spiral toolpath right here, I programmed this entire part but didn't save it. Later on, an application on my computer crashed and it took out Fusion as well, and when I opened the file back up, all my toolpaths were gone, but the video footage was recorded. So I went through and quickly reduplicated everything and did setup 2 and 4 after that. However, when I applied the spiral toolpath, if you note in the video, when on the
the force setup, if you look at my spiral, it goes from the inside out, which would be bad. But if you followed along the steps that I did for the first setup, it's going to go outside in, which is what you want. So that's an example. I'm curious to see what other things that you guys can spot as you watch the cam and then when you watch the machining video happen. I now return you to your scheduled cam broadcast.
One of the things I often see people do with parts like this is they just go with the de facto, I'm going to face the part. And I don't see any reason to face this part because there's no flat face at the top of the part anyway. We got the dome shape. And if we face this part, we're only going to take a few thousandths off and we have a long ways to go till we get to the finished part face. So instead, what I'm going to do in this part is I'm just going to rough the whole part out by going to the 3D menu and selecting adaptive clearing. I'm going to go grab a tool from my library, and the tool I'm going to use is the one that I just modified, tool number 2, the 3/8 inch end mill, and I want to select the adaptive clearing preset. For my geometry, if you remember in my last video, I talked about nothing means everything. I'm not going to select anything for geometry. I'm going to let Fusion figure it out. Fusion knows what the stock is, it knows what the model is, and it knows what the tool is, at least for 3D operations it does, and it's going to be able to figure out what it is that I want to machine. I'll move on to my heights tab. On my heights tab, I'm going to start cutting from the top height of stock top, and I'm going to cut all the way down to the model bottom, but I want to go 20 thousandths of an inch past the bottom of the model for when I flip it over so I don't have any height mismatch. Instead of typing 20 thousandths of an inch here though, I'm going to type in minus 0.03. And you'll see in a second why I decided to make that change of 30 thousandths when I told you I only want to go 20 thousandths past the bottom. I'm going to move on to the passes. I'm happy with the optimal load. I could probably increase the percentage of step over based on watching it cut the cylinder now. That was the first time I'd ever used this tool, so I was a little on the conservative side. But it's going to go pretty quick. It's a pretty small part, and I think I'm going to leave that optimal load right where it is. If I move down to my maximum roughing step down, this part is going to need to go, the tool is going to need to go roughly 0.82 inches deep to machine what I've asked for, and that's a little outside the 2 times diameter rule that I go for. We might be able to make it work, but I'm just going to split the difference a little bit, and I'm going to set my maximum roughing step down here to be 0.42. I just want 2 step downs in this part. When it roughs this dome, it's going to leave kind of a terraced effect on it, and what I want to do for the terrace is I just want to make this a little bit smaller, so I'll say 0.03, and that'll just leave a little bit smaller notches for the ball mill to come and clean up. Do a couple more things. I'm going to turn on something called order by area. I want the tool to do all the work it can in one spot before it moves somewhere else in the part if possible. And then I want to leave some radial and axial stock. I'm going to set my radial to be 0.01. And when I do, you'll notice that the axial follows along at the same time. This is why I went 30 thousandths of an inch below the bottom of my part, because I'm asking the tool to pull up 10 thousandths of an inch everywhere, including on the outside boundary of the part. I'm going to turn on smoothing, and I'm happy with the default there. And now I'm going to move to the linking tab. I'm only going to do a minimum retraction here. This is a great toolpath for making sure it retracts just enough to clear everything without having to worry about it. And I'm going to set my stay down percentage to 80%. So I'm taking this 1.875 and adding 80% of that distance back to that number to increase how much the tool stays down by. If it does have to retract while it's staying down or move back to the beginning while it's staying down, I'm going to tell Fusion to move back at 400 inches a minute while it's cutting through the air to get back as quickly as possible. And I think that's all the changes we need to make for this adaptive. I'm going to hit OK. And the thing I'm looking for is I just want 2 step downs. I don't want to see 2 small step downs at the very bottom of the part. I just want to see 2 primary step downs. If I go and I simulate this, I'll make this go just a little bit faster. We'll see that it just starts decking off that bit of material from the outside in, and then it's going to step down and rough out the rest of the part. We're looking at a cycle time of roughly 2.5 minutes. When we do the video, you guys will have to pay attention to how close that estimate actually is for what it's doing. And now it's doing the little step ups. It's going to take that material off, and you'll start to see it work on the dome and removing material so that the ball mill doesn't have quite so much that it has to remove. So there's what my part's going to look like when it's done with the roughing operation. I'm happy with that. I'm going to exit my simulation. And now what I think I'd like to do is I'd like to add a finishing pass around the outside perimeter of the part. To do that, I'm going to select 2D contour. I'm going to use the same end mill, but I'm going to use the finishing profile that I chose. Instead of going and selecting the tool and choosing it, notice that there's a preset field right here that I can drop down, and I'll say aluminum finishing, and I get my 2,000 feet per tooth and my 60 inches a minute. For my geometry, I just want to grab the chain of geometry at the very bottom of the part. And for my heights, I'm going to cut down to the selected contours, and I'm going to go negative 0.015. I won't go quite as deep, just by a little less, and that'll cut past the bottom of the part and finish that entire face. On the passes tab, I think I'm happy with everything here. I have my finishing overlap already set. I have my feed rates. I'm good with that. On the linking tab, I'm gonna set my lead and sweep angle to 0, just like I did on the cylinder. I'm gonna uncheck use same as lead in for the lead out, and I'm gonna lead out at a 45-degree angle. And then I'm gonna choose my preferred lead in position, and I'm gonna use that same point that I did in the cylinder. So a lot of this is the exact same as what I grabbed in that cylinder. In fact, I could have probably opened that part and copied the toolpath off and just pasted it on here. I'll hit OK. And now I get a 2D contour that just cleans the outside perimeter of the part. I left material on all the flat faces, and I could certainly go around with 2D contours or 2D pockets and do those faces one by one, but there's a more automated tool for that, and the tool I'm going to use for this is going to be 3D flat. Again, I'm going to use the same tool to do that. I'm going to choose the aluminum finishing toolpath for this, and now I just want to go over to my geometry tab, and what this tool does is it automatically finds any face that's horizontal and automatically machines it. So that's going to be the top face and any of these pocket faces down here. It's not going to go any lower below the part because there's no flat faces down there, which means in the heights tab, I'm completely fine with it cutting from the stock top to the model bottom because it's only going to find horizontal faces. So I don't have to worry about it crashing into my vise or anything like that. I'll move over to the passes tab. On the passes tab, I'm going to enable some options. I'm going to leave the default type as pocket or other as profile or parallel. I'm going to set this to be spiral as one of the types. I want to tell Fusion that it's okay to cut both directions instead of climb only. We're just taking 0.010 of an inch off the face of the part, so that's going to be no problem. And then I'm also going to tell Fusion it's okay to machine over holes so it doesn't try to lift up over the holes it sees on these flat faces. So I think I'm okay with all the options that are there. The final option I'm going to do on the linking is to tell Fusion to do a minimum retraction. Just lift up as high as you need to, or as best you can so that you don't crash into anything. I'll hit OK. And now what we'll see is without selecting anything, Fusion will go and machine all the flat faces on this. Now there is a problem. It's using the finishing step over amount, which is way too small. So let me edit that. I'm just going to go over to the passes tab, and there's where my step over value is. I'm going to change this to, if I want, I could just go and say reset to system default, and that's what it would have chosen if I didn't have a preset already set for this tool. I'll hit OK, and now we'll see a new toolpath that has much larger step overs calculated, and it should appear on our part much faster. I'm going to simulate this just to see what we get. Remember, anything that's blue is remaining stock, anything that's green is finished part. And if we slow this down a little bit, you can see it's just doing a cleanup pass across each one of those faces. Now it's going to step up on the top and cut across. It'll cut across, and then now it's going to go back the other way and just finish that top surface, and the flat toolpath is done. I'm going to do a 3D surfacing toolpath to do this dome. And that toolpath is going to be from the 3D menu, the spiral toolpath. I'm going to grab a new tool out of the library, and this time I'm going to go and grab tool number 4, which is a 3/8 inch ball end mill. And I'm going to go grab the aluminum finishing preset and select that. You can see that this is going to run at 10,185 RPM. That's a bit of an issue for a lot of the machines that I see that don't go over 10,000. I can go up to 12, so I'll be okay with 10,185. But I think I want to make one adjustment. It's cutting at 159 inches a minute. I'm going to change the feed per tooth down to 0.003. When I do that, you can see it'll change my cutting feed rate to roughly 90 inches a minute, which should hopefully give me a better surface finish on the part. I'm gonna move to the geometry tab. It's asking me for the center point that it wants to do the spiral around. I'm just gonna click on that circle right there, and you can see the white point that designates where the center is. For the machining boundary, I'm gonna say I wanna do a selection, and I'll choose this edge, and I want the tool center to be on the boundary. I'm gonna turn on contact point boundary as well, so the tool gets all the way out there. And now I'm gonna go to the passes tab. I'm gonna look at the direction it's cutting, so it's gonna do shortest machining path. What I wanna do is, I wanna do outside to in. I've got the outside finished, I want it to work into the center, so I'm just gonna force it to go outside in. It's gonna do a spiral, and I'm gonna set my step over to be 0.01. I wanna keep this toolpath within 2 or 3 minutes. I don't need a super great finish on this, but I also want it to look somewhat nice. Gonna keep going down and looking. I think I'm happy with everything else that's on this option. And the last thing I'm gonna do is go to the linking. I'm just gonna change the retraction policy to be a minimum retraction, and I'll hit OK. And we'll see the toolpath, rotate around and look at it. It looks pretty good. Did anybody else catch an issue? I don't know what this, I don't want this if I'm going to machine this part. I don't want to have this kind of figure 8 move here. And I'm guessing I know what this is. It's either we need to change the tolerance of the model, or I'm going to try to change the tolerance of the additional offset by doing minus tolerance. If you're not sure why I'm doing this, I'll leave a link to a video where I explain this whole, what this contact point boundary does in the additional offset. And now I'm gonna hit OK. Let's take a look if it cleaned it up. And now I can see that, yeah, I get a nice arc in. I'm happy with that. And that's going to machine that dome complete. I'm ready to go and drill some holes now. So I'm gonna grab a drilling operation. I'm gonna spot drill this first by going to my Autodesk Model Engine project, and I'll grab tool number 5, which is my 1/4 inch spot drill. And I'm gonna choose aluminum drilling as the preset. And I'll just go grab the faces that I wanna machine. I could have used select same diameter, which would have saved me some time. Not sure why I didn't use that there, but I could have just checked that box and it would have grabbed everything automatically for me. I think I'm gonna put that on. It leads in a slightly better place that I'd like it to, in the front where I can see everything better for the first operation. So I'm gonna turn select same diameter and let it grab those. On the heights, I'm gonna cut from the whole top for the top height, and for the bottom height, I'm also gonna go to the whole top, and I'm gonna do a minus 0.05. Now, when I'm programming things for myself and I'm not trying to do it in video form, I have some templates saved for this, so that these values are already set for me, so I don't have to go through and change these, which saves me time. On the cycle tab, drilling rapid out is gonna be just fine, and I'll hit OK, and there's my spot drill. I'm gonna do another drilling operation. I'm gonna select my tool, and if I hit cancel here, remember if I hover over a hole, it'll tell me that that's a 0.201 diameter hole. I'm gonna select a tool out of the library, and I'm gonna go find my 0.201 drill, which is tool number 9. Aluminum drilling is selected. I'm going to select that. I'm going to go to my geometry. I'm going to click on one of the holes and say select same diameter. And I'm going to check something. We might be able to come back and make this drilling toolpath a little efficient, but I have to pay more attention to the previous toolpath where it started and ended. On the heights tab, I want to cut from the whole top to the whole bottom. I want it to go all the way through, so I'm going to just say drill tip through bottom, and I'm going to cut past by 50 thousandths of an inch. On the cycle tab, I'm going to do chip breaking, partial retract, and I'll hit OK. And you can see it's leading in on this hole and then working around clockwise. If I go to the previous hole, you can see it's doing the exact same order. So what I can do with this, I'm going to go edit it. I'm going to go to the geometry tab, and I'm going to tell it that I'd like to reverse the order. I want it to start where it just ended. So now it's going to end in this hole, and then it's going to start in this hole and go counterclockwise for the next set of holes. So that takes care of my drilling, and all I have left to do now is add some chamfers. The chamfer on this part has been modeled, and so I'm going to use 2D contour to add this chamfer to the top of the part. You can use 2D chamfer to do it, but it requires you to understand more about how the toolpath works, so I'm just going to use 2D contour to do this instead. From the 2D menu, I'm going to select 2D contour, and I'm going to go to my library and grab tool number 12, which is my 45-degree chamfer mill. And I'll hit select, For the geometry, I want to choose this chain of geometry at the very bottom of the chamfer. And now I can move right over to the passes. I don't need to worry about heights. Everything is being dictated by the tip of the tool and the geometry that we set. Fusion has detected that we're using a chamfer tool and wants to know what the chamfer width is. If the chamfer's been modeled on your part, you can leave this value set to 0. For the chamfer tip offset, it's asking me how far do I want to offset the tool past the bottom of the part. And I'm going to try 60,000ths of an inch and see how close that gets me to hitting the floor. That's my determining factor. I don't want to cut into the floor below the chamfer. I'd like to cut down as far on the slope of the tool as I can to get towards the top where I get a better surface footage where I'm going to get a better cut. I should also note that because I'm using 2D chamfer, my finishing overlap is already set. I'm going to go to my linking and one more time. I'm going to set my lead in sweep angle to 0, my lead out sweep angle to 45, and my preferred entry position to this point, wrong point, to this point right here. Again, I have templates set up for this, so I don't have to go through and change all those numbers. I have templates set up that have the proper lead in and lead out angles for doing operations like this. I'll hit OK and we'll take a look and see what we get. That toolpath looks fine. What I want to make sure is I'm not getting too close to that floor and it looks like I have plenty of room there. So that's just going to go around and cut that 20,000ths of an inch chamfer. We'll chamfer the holes around the part, so I'm going to do 2D and 2D chamfer for this. Same tool. The geometry, I'm going to click on my 4 edges starting with that hole right there because that's closest to where it finished for the 2D chamfer or 2D contour for the last operation I did. On the passes tab again, one of the things I'm going to do is turn on preserve order so that it machines the selections in the same order that I selected them in when I clicked on those edges. I'm going to go down to the chamfer width. I'm just going to do a 10,000ths of an inch chamfer, a 40,000ths tip offset, it's going to be fine. And I'm going to set this to be 0.001, and we're going to see in the very next toolpath exactly what this controls. On the linking tab, I shouldn't have anything to do. I'll just hit OK. And now I get a chamfer toolpath that goes and does my 4 holes. For the last toolpath, I'm going to select 2D chamfer, same tool. And for this, I'm going to select my same 4 edges. So I'm going to select this edge, this edge, this edge, and this edge. I'm going to go to the passes tab. Now for this, I want a 20,000ths of an inch chamfer. And my chamfer tip offset, we're going to talk in a second about how I calculate that. I'm going to set this to be 0.075 for this particular instance. And I'm going to set my chamfer clearance to 0.001. This number is going to come into play in a big way on this toolpath that I'm adding. I'm also going to tell Fusion I want to preserve the order so it starts in this corner so I can watch it really nice in the first one and then it'll go around and do the other 4. No other changes needed on my linking tab, so I'm going to hit OK. And we're going to take a look at another little drawing I have, and then we're going to come back and talk about that chamfer that I just created. So here's a sketch of my chamfer tool. It's a 1/4 inch in diameter. It's 90 degrees, so 45-degree included angle. And the tip of this tool is 0.044. I left off a dimension, so let's just edit the sketch quick. What that means is if I do a dimension from the bottom face to this edge, that the deepest I can go with this tool before I cut past the shoulder is 0.103. The chamfer that I'm asked to do, 0.103 minus 0.02. That tells me the deepest I can go with this tool without cutting past this edge is 0.083. I chose 0.075, which is getting me really close to the tip of where this intersection is right there. So now that we know how I calculated that, let's go back and talk about those fields. If I edit this and I go to the passes tab, this chamfer clearance is going to keep the tool, the vertical part of the tool, the shank of the tool from running into this vertical wall by 1/1000th of an inch. A lot of times that makes people uncomfortable, but if you think about it, when you buy tools, they're almost exactly on size. So this is a 1/4 inch tool. I would bet that it's always going to be a 1/4 inch or less, maybe a little bit less depending on the stock that they're using, the rod stock that they're using to create this chamfer tool. So I'm gonna be okay with that. I'm good with my my first setup. Let me turn off the model, and what I want to do is just go simulate this with the model off. Now whatever I see is what I'm going to get, and I might let this go a little bit faster on the adaptive since we've already watched that play one time, and then we'll pick it up maybe from the flat on. So there comes my flat. It's doing its thing. We're going to see the spiral. I'll make this go a little bit faster so we don't have to wait for the whole thing. When the spiral is done, it's going to spot drill the 4 holes. So that's good. I'll slow down just a little bit now. So we're going to come spot, 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 drill, 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 reverse direction, and it's doing the chamfers and does the other chamfers. And now here comes the magic chamfer after it does this last hole. The reason I call it the magic chamfer is this stops you from having to deburr that edge. You can see how close we actually get, and it stops the tool before it runs into the vertical wall, so it deburrs as much as that edge as possible without me having to take a hand deburr and do that, which I'm never going to make it look as nice as the machine does. So that's why I left the chamfer off when I modeled this part, because it's just easier for me to do it in CAM and get the same result. So this is what our part is going to look like at the conclusion of the first setup. And now I can go get ready to set this part up for the second operation and get rid of that Hatta material. For the second setup, I'm going to flip the part left to right. So I'm just going to rotate this around, keeping the front to the front, and the left is going to become the right, and the right will become the left. Now, when I put this in the vise, I'm going to clamp on this face and this face. That's what the vise is going to clamp on. And then this face is going to rest on the parallels. So I want to put my work coordinate system at the center of the part, at the center of that coordinate system of that face right there. So I'm going to go and create a setup. And you can see my Z is going the wrong direction, so I'll just click on the Z arrowhead, and the X is going the wrong direction, so I'll click on the X arrowhead, and now I'm happy with that. I'm currently located on the stock box point, and what I want to be is on a selected point, not a model point. A model point would be the tip of the dome. I want to be in a selected point, and I'm going to select that circle right there. Now if I look at that, I'm right on that face I was talking about at the exact center of the part. So I'm happy with that, and I'm ready to move on to the stock tab. I'm going to choose from preceding setup and continue rest machining so the stock looks the same as it does after op 1, and I can hit OK. All I have to do in this particular setup is rough off the majority of the hat and then just do a facing tool pass. So I'm going to start out by doing a 3D adaptive clearing. I'm going to go select a tool out of my library, and it's going to be the Autodesk Model Engine library. It's going to be tool 13, although before I post this, I'm going to change this to be tool 10. On the geometry tab, I'm not going to make any selections. I'm going to say none, let Fusion figure it out. But on the heights, I don't want to cut all the way down to the model bottom. I want to cut to the model top. My goal in this operation is just to remove the hat of material so I can more accurately touch off on the machine faces of the part for the next setup. On the passes tab, I'm pretty good with the 0.2 step over and the 0.2 step down. All I really need to do is set my radial stock to leave to be minus 0.05 because I want to cut outside the bounds of the part on the wall stock, but I want to leave some floor stock, which is axial stock, of positive 0.01. I'm going to turn smoothing on, and then in the linking tab, I shouldn't really need to have to worry about it, but I'll do a minimum retraction. I'm going to set my state on level to 80% and my no engagement feed rate to 400. And I don't expect this tool to lift at all, but in case it does, that's why I set those numbers. And now I can hit OK, and we should just see a spiraling toolpath that roughs off the Hatta material. And the next thing I want to do is a facing toolpath using the same tool. On the geometry tab, I'm going to make one change on the tool tab. I don't want to cut at 200 inches a minute. I'm going to change my feet per tooth to be 0.005. That's going to half it down to 100 inches a minute to give me a slightly better surface finish. The geometry, I'd be okay hitting the OK button now, but really the only stock I have is exactly on the top of the face. So I'm going to click on the top face of my part to tell Fusion that's the only place it has to worry about stock being. And then I can jump over to the passes tab. I'm going to increase my step over to 1 inch. I could go a little bit more if I wanted to, but 1 inch should be enough. And I'm just going to put a small 20,007 inch stock offset here to make sure it gets past the sides of the part. I only want a climb cut for this, so I'm going to set that to be climb, and everything should be good. I'll look at the linking tab just to make sure extend before retract is on. It is. I'll hit OK, and I should just get a couple passes going across there to take that last 10,000ths of an inch off. And there we go. I'm done with my second setup. Might be a good idea if I hit save now. And then for my final setup, what I'm going to do, it's almost going to be an exact duplicate, except for all I have to do is surface in this other dome drill the holes and chamfer my edges, and I'll have this part complete. I'll start one more setup. Again, click on the Z arrowhead to flip it, the X arrowhead to flip it, and I'm gonna choose a selected point to be at the exact same point I was just at for the Z. I lied, I want to do something completely different on this. I want to be on the left face in the back face at the corner. I don't want to be in the center for this part. So that means that I need to go back into CAD and do a little bit of work, because I don't have a point at the intersection of those planes that I can use, but there's a really easy way I can do it. If I come back into Fusion CAD, again, I want to set this so I know which face I'm on. So my right is going to be on the left for the backside. On the construction drop down, I'm going to choose a point. I want to point through 3 planes. So I want this face as one of those points. I want this face as one of those points. And I want this face as one of those points. So now I'm on that same face, but I can touch off on my 2 edges, and now I can hit OK. I'm going to come back into manufacture. I'm probably going to get setup 4 now since I canceled a lot of that one, but that's not the end of the world. I'll just say new setup. And I get setup 4. I can maybe rename that if I want to. I'm going to choose a selected point, and the selected point is the one that I just created over there. So it's still on the bottom of the part, but it's the X and Y. And I have my X and Y going the wrong direction, so my X and Z going the wrong direction. So I just click on those 2 arrowheads to get them facing the way I want to. And now you can see I'm on that bottom face, but if I look at it from the top, I'm at the intersection of those 2 faces, so I can use my Heimer to touch X and Y off of those exposed machine faces for me now. On the stock tab, I'm going to say from proceeding setup, and I'm going to choose continue rest machining. Post-processor tab, I'm going to use G54 one more time, and I can hit OK. And now I'm ready to finish up that machining on this part. I'm going to start out by doing this domed cut area, and I've already got my work done. I just have to steal my spiral toolpath, so I'm just going to copy that toolpath and right-click on my new setup and paste it in there. And now that I have that pasted, I can expand this out, grab that spiral toolpath, and then I'll just go and throw some things away. So for my center point, it's going to be this edge. For my machining boundary, it's going to be that edge. Everything else about this toolpath is going to be exactly the same. So I can hit OK. It's going to cut from the outside in. And notice I didn't try to rough this. It's only going a 1/16 of an inch deep. If I switch back to design and I find the sketch that controls the revolves, I could use the measure command and click here to here, and you can see our depth is only a 1/16 of an inch. So we should need to worry about roughing that material out first. I'll come back to manufacture, and all I have to do now is spot drill a couple holes. So I'm going to do a drilling operation. I'm going to select my spot drill from my project. Actually, I can do it from my document because I've used it before. And I want aluminum drilling. And now I'm just going to click on the 2 holes that I want to spot. So I'll just choose that face and that face. On my heights, I'm okay with the whole top, but for the bottom height, I'm again going to use 2 chamfer width and set my chamfer width to be 10,000ths of an inch just to put a little chamfer on there. The cycle drilling wrap it out will be just fine. I can hit OK. Now I'll drill the 1/8 inch holes. I'll go select that tool out of my model engine project this time. There's tool number 6, the 1/8 inch drill, aluminum drilling as the preset. And I'm just going to click on my 2 hole faces that I want. And then on the heights tab, only change I need to do is drill tip through the bottom. We're only going 1/8 of an inch deep on this, so I'm not going to peck. I'm just going to go for it. And I'll hit OK. Again, I want to look at this. So I plunge on the spot drill. I plunge here and retract here. And notice that now I'm plunging here and retracting there, so I don't need to change the order. The last thing I need to do is just chamfer the holes. So from the 2D menu, I'm going to select 2D chamfer. I'll select a chamfer tool. I should have that in my document that I can grab, tool number 12. And I'm going to select that, grab my edges. So it's going to be the outside edge. And then I'll select the 4 holes, and I'll have that do that in a somewhat similar way. So I got the face instead of the hole, so I'm just gonna X off that last hole. There, we click on that, and that, I guess it's not bothering anyway. And then I'm gonna go to the passes tab. Now what I don't want is I don't want to go too deep with this because I know I've got a vice jaw somewhere here. So I'm just gonna run with the defaults of 440 thou for a champ tip offset, and I'm gonna do a 0.01 edge break on here. My chamfer clearance is also going to be 0.001. Nothing I really need to change on the linking tab unless I want to say, please lead in here first so I can watch it. And now I can hit OK. And I get the chamfer toolpaths that'll finish this part up. So with that, my part is completely cammed and I can start posting code and go set up on the machine. So come back on Saturday and we'll see how this part turns out with my machining techniques that I used here. Hope you guys are liking these videos and picking up some things and learning some things. Love it when you leave comments. Hopefully the pace is okay. I know, again, this was a slightly longer video. If you have any questions, please leave them down in the comments below. If you found this useful, please give it a thumbs up and consider subscribing as well. As always, thanks for watching.